In this lesson, we are going to learn how to graph simple rational functions by hand. So remember that when we talk about rational functions, we're talking about fractions. The parent function is y equals 1 over x. And we learned in the last lesson what that function looks like. So if you recall, the parent function is centered at 0, 0. It has a horizontal asymptote and it has a vertical asymptote. And one of the critical points on either side of this function is over 1, up 1, and over 1, down 1. Now that's what the parent function looks like. In this lesson, we're going to learn how to shift that function up, down, left, right, and stretch it out. So you may recall from some of our previous lessons that the constant with x is what's going to shift your graph left and right. For example, if you had x plus 3 in the denominator, that's going to shift your entire graph to the left 3. Whereas if you had x minus 3, that's going to shift your entire graph to the right 3. The constant at the very end of your function, remember, is what moves your graph up and down. So if you had something like 1 over x and a plus 3 at the end, that's going to move the whole thing up 3. But if you had a minus 3 at the very end, it's going to move your graph down 3. So the constant shifted up, down, left, and right. The value at the top of your fraction, your a value, this is going to be the number that will either stretch or reflect your graph. So if you've got something like 3 over x, it's going to stretch your graph out. A reflection would happen if you have a negative thrown in there. So if you have something like negative 1 over x, it's just going to flip your graph over to the other side. So let's see what some of these look like. Let's take a look at a few examples. The first one, we have y equals 1 over x minus 1 minus 4. Well, the x minus 1 we understand is going to shift our graph to the right 1, and the minus 4 is going to shift our graph down 4. So what I want to do is I want to center my graph, and I'm going to go ahead and draw like the horizontal and the vertical asymptotes. So instead of starting at 0, 0, I'm going to go to the right 1 and down 1, 2, 3, 4. It's going to be centered right here. And right there I'm going to draw my horizontal asymptotes through that point, and I'm going to draw my vertical asymptotes through that point, just indicating those with dotted lines, because remember, an asymptote is an imaginary line that the function approaches but never quite reaches. Now, to actually draw my function, I'm going to start with that first critical point. Since we have just a regular 1 on top, from the center where my vertical and horizontal asymptotes intersect, I'm just going to go over 1, up, and I'm going to come down and around through that point. And same thing in the opposite quadrant. We're going to go over 1, down 1, and I'm going to come down and around, being very careful to never cross over those asymptotes. Let's try another example. The next one, we've got y equals negative 1 over x plus 2 plus 5. Now, x plus 2 will shift our entire graph to the left 2. And the plus 5 will shift the entire thing up 5. So we're going to start there and draw our asymptote. So instead of starting at 0, 0, we're going to go to the left 2 and up 1, 2, 3, 4, 5. Okay, so we're starting here and we're going to draw our horizontal asymptotes and our vertical asymptote through that point. Next, I'm going to focus on that negative 1, and I'm going to draw my curve. So negative 1 indicates that it's going to be flipped. So instead of going over 1, up 1 to the right, I'm going to go over 1, down 1. And I'll come up along that asymptote and bend around to the other side, being very careful not to ever cross over those asymptotes. Those are the boundaries of your functions. We're going to do the same thing in that opposite quadrant. So I'm going to go over 1, so back 1, up 1, And again, we'll curve down and around through that point, being very careful never to cross over the asymptote. Our final example here, we've got y equals 4 over x plus 3 minus 1. Again, I'm going to start with the asymptotes first. X plus 3 indicates that the entire graph is going to move to the left 3. And the minus 1 tells me that I'm going to shift down 1. So we're going to start there. So instead of at 0, 0, we're going to go to the left. 1, 2, 3, and down 1. So that's where I'm going to draw my horizontal asymptote, and that's where I'm going to draw my vertical asymptote. Now to draw the curves themselves, I need that first critical point. Notice I have a 4 on top instead of a 1. So remember the parent function usually goes, or the parent function always goes, over 1 up 1. Here I'm stretching that out by 4. That could happen two different ways. You could either stretch it out by going over 1 up 4, where you make that stretch in the vertical direction, or you could reverse that and go over 4 up 1, where you only make that stretch in the horizontal direction. In fact, I'm going to plot both of those points. Instead of going over 1 up 1, I'm going to go over 1 up 4 and plot a point. I'm also going to go from that center, I'm going to go over 4 up 1 and plot a point. That way I have a little bit more to go off of as I come curve down and around. And then the same thing on the opposite side. I'm going to go over 1 down 4. I'm also going to go over 4 down 1. And I'm going to curve down and around, being very careful never to cross over those asymptotes. So you can see how much this is stretched out. It looks like somebody has pulled that function away from the center. Having that 4 up top just creates a little bit of a stretch in your graph.